You know, for thousands of years, the game of Go hasn't just been a game. It's been seen as this mirror to the mind, a way to understand what it even means to understand something. So this is the story of a machine that learned to look into that mirror. And what it saw there, well, it pretty much changed everything.
I mean, listen to how people talk about it. Experts describe playing Go as this incredibly profound, almost hypnotic experience. It's like it pushes you to the absolute farthest reaches of what you're capable of. It's not really about just winning or losing a game. It's about facing the very limits of human thought.
So that brings up a really big question, right? What really happens when a machine starts to get it? When it starts to understand this game that we've held up as a pinnacle of human intuition for millennia, better than we do?
All right, so let's dive into why this was such an impossible challenge. For decades, you see, AI researchers looked at Go as way more than just a game. It was their holy grail. I mean, computers had already cracked checkers, they'd conquered chess, but Go just felt different. It felt like this unconquerable peak of human intellect that raw calculation could never, ever reach.
And to really get why, you have to wrap your head around this number. This is the number of possible board positions in Go. That is a 1 followed by 170 zeros. It's a number so huge it's bigger than the estimated number of atoms in the entire known universe. Think about that. You can't just calculate your way through something like that. It's just impossible.
And this isn't just a numbers game, like chess. In chess, a computer can, for the most part, brute force its way to the best move. But in Go, with its huge, sprawling board, winning comes from something way more abstract, a feel for the game. We call it intuition, and that's something that's notoriously incredibly difficult to just program into a machine.
And this sentiment really captures what everyone was thinking at the time. The best computer scientists in the world had tried and failed for decades. Seriously. The general feeling was, wow, this is just too hard. Most people believed that solving Go was a challenge for another generation, maybe even another century.
But then, a completely new approach popped up. The team over at DeepMind, they didn't try to program the rules of intuition. Instead, they decided to build an AI that could learn it. And this was the very first AlphaGo.
So how on earth did it learn? Well, it was a pretty cool two-step process. First, it was like an apprentice. It studied 100,000 games played by human experts to learn the basic patterns. But then, and this is the key part, it started improving all on its own. It played millions and millions of games against itself, getting just a little bit smarter with every single win and every single loss. That second part, that's a powerful idea called reinforcement learning.
So what was going on under the hood? Well, AlphaGo's brain had two main parts, two neural networks. You can think of them as two specialists working together. First, you had the policy network. That was the strategist, the one asking, okay, what are the best possible moves right now? Then you had the value network. That was the judge, looking at the board and asking, all right, from this position, who's winning?
And the first real sign that something incredible was happening came back in 2015. AlphaGo played the European Go champion, Fan Hui, and beat him 5-0, a clean sweep. This was a massive shock. I mean, the entire AI community thought a milestone like this was at least a decade away, if not more.
Okay, so beating the European champion, that was one thing. But to really, truly prove itself, AlphaGo had to face a living legend. It had to go up against Lee Sedol, an 18-time world champion, widely considered the greatest Go player of the decade. This was the real showdown.
And heading into this historic match, Lee Sedol was confident. And you can't blame him. He said he'd win 5-0, or maybe 4-1. The entire Go world was right there with him. For them, for everyone, the game had this depth, this creativity that a machine just couldn't possibly understand or replicate.
And then, this happened. Game 2. AlphaGo plays Move 37. And it was a move so strange, so alien, that the expert commentators were just baffled. They thought it had to be a mistake, a bug in the code. But it wasn't. It was a move of profound, almost unsettling creativity that completely changed the game. In fact, AlphaGo itself had calculated that the probability of a human master ever playing that exact move was about 1 in 10,000.
But the story wasn't over. Not yet. In Game 4, with his back completely against the wall, Lee Sedol delivered what the world now calls the God move. Move 78. It was just a moment of pure human genius. It turned out to be the one and only move on the entire board that could win him the game, exploiting this tiny, almost invisible blind spot in AlphaGo's otherwise perfect knowledge. For one beautiful moment, humanity found a crack in the armor.
In the end, though, the final score was AlphaGo 4, Lee Sedol 1. It was, without a doubt, a historic victory for artificial intelligence. But that one win for Lee Sedol, that God move, it was such an incredible testament to the resilience and the sheer brilliance of the human mind.
So after beating the best player in the world, you'd think they'd be done, right? But the team at DeepMind asked an even deeper, more profound question. They had built this machine that could learn from all of human knowledge. But what if it could do even better if it learned from nothing at all?
And this question was huge. Could an AI, starting from a complete blank slate, what philosophers call tabula rasa, with only the absolute basic rules of the game, could it teach itself to play and in the end actually surpass thousands of years of human strategy and wisdom?
And this new system, which they called AlphaGo Zero, was just beautifully simple. Instead of two networks, it used a single, much more elegant one. It didn't study a single human game. Zero. Its only teacher was itself. It just played millions and millions of games, learning purely from its own experience.
The results were absolutely staggering. In just 36 hours of self-training, it became strong enough to demolish the version that beat Lee Sedol. After 40 days, it had become, without question, the strongest Go player that has ever existed, human or machine. And it was discovering entirely new strategies, ways of playing that were completely beyond human comprehension.
Okay, so this is where it gets really interesting. The final step, and maybe the most important one, was to see if this incredible learning engine could be generalized. Could it learn more than just the game of Go? So by stripping out any knowledge that was specific to Go, the researchers created a truly general algorithm, AlphaZero. The goal was to see if this core engine could master any game of perfect information. You know, any game where both players can see the entire state of the board, like Go or chess. And it worked. Amazingly. They took this exact same single algorithm and just set it loose on chess and shogi, which is Japanese chess. And in both cases, starting from nothing but random play, it taught itself, and within hours, it had completely crushed the world's best specialized computer programs for those games, Stockfish and Elmo.
You know, in the end, AlphaGo didn't just beat humans, it actually taught them. The new strategies, these beautiful, creative moves it discovered, they have fundamentally changed how this ancient game is played. They're going to influence how Go is played for the next 1,000 years.
And that leaves us with this one final, tantalizing thought. The journey from AlphaGo to AlphaZero, it isn't just about games anymore, is it? It's a proof of concept for a general problem-solving system. So if this approach can find new, beautiful, and superior solutions in a 3,000-year-old game, what could it discover when we point it at our oldest and most complex real-world problems? Things like science or medicine. What beautiful discoveries are out there waiting for us just beyond the edge of what we currently understand?